Good morning, everyone. Welcome back to Boostedy Statistics and Business Academy. This is a continuation of the calculus series. Okay. Today again, that we're gonna get into some kind of a complicated or complex calculus problem, which is heavily found in Calc 1, Calc 2, Calc 3, calculus with analytical geometry, or just simply in calculus. Okay. Anyhow, let's straight go to the question and see how this can be tackled. Okay. Thank you. I'm going to write it down the question. Okay. Q stand for question. Okay. Determine g of x and all values of c. C. Okay. C. C such that this integral going from c to x gt dt. See, t is this is like a dummy variable. See, t dt. It's nothing but x squared plus x minus 6. See, that's our question. We have to find g of x, not gt, g of x, and all values of c in such a way that if this kind of a relationship has been given, this has been given. Very good. You're trying to see this block inside the integral. Now you have to take it out. In order to take that out, you have to do the anti-integral. Anti-integral means nothing but the derivative. This time you're going to take the derivative on both sides. Okay? Take derivative or differentiate both sides. Okay? To make it more professional, I'm going to say let this integral c to x gt dt is nothing but x squared plus x minus 6 differentiate both sides with respect to, I'm going to write abbreviation in my previous videos. I talk about that, how what this WRT stand for with respect to x not t, x, because this side is this is like a function of x. See, function of x. See? That's not g of x. Okay, this is not g of x. This is related to this one. Okay, let's differentiate. Let's differentiate the integral. Okay, I'm trying to differentiate the integral. Okay. That means I'm going to write this one very clearly. I'm eyeing for d of dx of this guy, c to x, gt dt. Okay, on this side. The other side, I'm eyeing for this one. Squared plus x minus 6. This side, I'm eyeing for this one. See, This is what I'm looking for. So I'm gonna erase this part. You don't need this one now. See, what do you think? If you integrate, what do you get? What's the formula say? They say the formula say, okay, forget what the formula say, okay? I'm gonna write here note of something like this. Let's say you have a f of x here, g of x here. You take the derivative with respect to x of ht dt here. See, something like that, okay? What the formula say? Formula say, get this function and replace, get the function and replace this t with gx. Not only that, try time derivative of that guy, g prime, minus upper bound. Then you're gonna put lower bound inside this guy, h f of x, and that should be multiplied by its derivative. See, that's what we do. Okay, that's what the formula says. See, derivative, derivative. See, that's the formula says. That's the formula. If you integrate a certain, if you differentiate a certain integral with the like a bounds, not the constant. This time you have what? Functions. See, functions. Function. We're going to consider this like a function. Doesn't matter, constant. At least this is a function of x. Eh? Then what are you going to do? You're going to replace this guy inside t with whatever the function times its derivative minus, you do the same thing for the lower bound. So therefore, in our case, look at g, t should be replaced by x, and x should be take the derivative of x, okay? Derivative of x. See, I'm going to write like that for your convenience. I can come back to that one later. See, derivative of x minus g of c. See, you're going to replace t with c and take the derivative of c. I'm going to write it down first, okay? See, which is equivalent to this derivative, 2x plus 1 minus 0. Excuse me. Now you know the derivative of this one, gx. Derivative of x is 1 with respect to 1. You can use that notation or this notation, prime notation, operator notation, minus gc times c prime is 0. The derivative of a constant is 0. And you're going to left out 2x plus 1. This is 0, the whole thing 0. Therefore, you easily left over with gx. Very easy. Therefore, gx times 1 is gx. On this side is nothing but 2x plus 1. 2x plus 1. That's how we're going to find the g of x. Then they are looking for what? Not only that, c value. Now you can go back to the original equation. Now, from this guy, you know, c to x gt dt is nothing but plus x minus 6. No? Can you remember? Now you know g of x. You can put it g of x here, see, easily. Okay. So if you know g of x from this one, you can set up when x equals t. You need the gt. Gt is nothing but you replace x with t, 2t plus 1. See? Plus 1. I'm going to put this one here. C to x 2t plus 1 dt equals x squared plus x minus 6. Now I'm going to erase this one too. Okay. Okay. Then let's integrate on this side. If you integrate, t become t squared over 2 plus t, then we have to plug in upper bound and lower bound on this side. That side, we're going to write whatever we have. 6. I'm going to get rid of this one too. Okay, then this one get cancelled off. Then let's plug in the upper bound. T replaced by x, that's upper bound, minus c squared plus c equals x squared plus x minus 6. So let's remove this parenthesis. Therefore, we have x squared plus x minus c squared minus c x squared, see, x squared plus x minus 6. So since they have the same positive, they get cancelled off. See, same letter, same power, same sign. So you are left over with minus c squared plus c. I'm sorry, minus c equals negative c. We can take everything to the one side to make like a quadratic equation of c. C squared plus c minus 6. See, I took everything to one side, to the right hand side. When you take this to that side, you have to switch the sign. Now I'm going to a little bit flip and write. Flip and write. Okay, so I would say c squared plus c minus 6 equals 0 for my convenience. Same thing. I flipped. Okay. You can get rid of all these for your convenience, for you to make it clear. So then there's a quadratic equation. So you can easily split this one, say, CC 3 times 2, but the greater number should be this one, this should be that. Okay. Therefore, you have C plus 3 equals 0, or C equals negative 3, or C equals 2. Okay. Okay. Then we got the C. Then you can verify whether this is the right C. How could you gonna verify? We know that this one, C to X gt dt equals x squared plus x minus 6. And later on we replace gt with c to x 2t plus 1. Can you remember? dt. See? Like that, sorry. Oh, if you want, I cannot do like this way, okay? That means I have to show that this side equivalent to the other side, okay? Let's get the left-hand side of this guy, okay? Left-hand side of this guy, okay? And we are trying to show that this C will satisfy this given equation. That means you have to start from left-hand side and show that you get the right-hand side or vice versa. Let's say I'm going to get left-hand side, which is going from C to X gt dt. Let's simplify this one. Forget about the right-hand side. We know gt. Gt is nothing but 2t plus 1 dt. We know this integral. See? So 2t squared over t plus t, going from c to x. That means you get t squared plus t, c to x. Okay. We can do another one. We can say when c equals negative 3. I'm going to write a one step here, negative 3 to x gt dt equals x squared plus x minus 6. So here we have negative 3. Negative 3. Negative 3. Let's plug in this. Upper bound minus lower bound negative 3 squared. I'm going to use the bracket, okay? Plus negative 3. I'm trying to plug in into this one and see whether the left-hand side is equivalent to right-hand side when c equals negative 3, okay? X squared plus x minus This one is minus 9 plus 9 minus 3 x squared plus minus 6. See, that equals the right hand side. Look at the right hand side. Therefore, you can say c equals negative 3. It's good. C equals negative 3 is good. But we will verify that. You see, right hand side. We pretty much do the same thing, okay, when c equals positive 2, okay. We're going to start from here. We know that C2 x gt dt equals x squared plus x minus 6 means C2x gt is 2t plus 1 dt should be equivalent to this guy when c equals 2 to x 2t plus 1 dt should be equals to this one. Then again, let's get the left hand side and work on that one and show that it is equivalent to the right hand side. 2 to x okay. Let's work on that one. Two t squared over 2 plus t go from 2 to x. That means t squared plus t go from 2 to x. Okay. Equals x squared plus x for the upper bound, lower bound 2 to the 2 plus 2. This equals x squared plus x minus this is 4 plus 2. This is nothing but x squared plus x minus 6. Therefore, this is equivalent to right hand side. So therefore, c equals 2 is a valid value. For 2 is a valid value for c. Therefore, c equals 2 also valid value. Okay. This is how we're gonna solve something like that. Okay. So we can meet you guys in another video. Until then, with a very interesting other calculus problem, some kind of a complicated complex, interesting, fascinating, appealing, or some kind of some heavy flavor, okay, something unusual or something like that, okay. Sometimes it's been found in textbook or maybe in somewhere online or somewhere, doesn't matter, it doesn't matter anyhow, that we really need to know how to find the solution for this one, how to find the solution. So until then, I'm gonna say goodbye and then see you in another video, and then you guys take care of yourself and be well, stay safe. Thank you very much. Have a good day. Bye-bye.